So homework. Hopefully, you guys are making progress with your packet. I'm going to check the remaining of your packets tomorrow. So tonight, you guys can finish up 61 to 68, and then tomorrow I'll check pages 43 through 68. Today, we're going to start our test review packets. One thing I want to make sure that, I don't know if I went over on the board here, is that there are different forms for arc length. So at the very beginning, we learned about arc length from 7.4, where it's just basically involving Pythagorean theorem and the derivative, and we're adding these infinitely thin curved regions. And then we learned about how parametric and rectangular form, we can split them up into individual components and say the square root of dx dt squared plus dy over dt squared. Likewise, with polar, we can adapt this parametric for dx and dy in terms of theta. So if we have x and y in terms of theta, we can break them into parametric parts as well. But if we have an equation that is just in terms of r and theta, we can also directly plug in to this formula. And this is kind of similar to rectangular form, right? Kind of has a similar feel. So parametric is similar, and then your rectangular in terms of x, or polar in terms of r, and d theta has a similar look to it. So it just depends on what's given to you and what's asked of you. Technically, you could present your answer in either form, but I just want you to be aware of both forms, because if it's multiple choice question, they could present a form in this, and if you only have this knowledge, then it's hard to get to this, right? So we want to make sure we know those rules. Okay, so today we're just going to see how much of worksheet 1 we can get through. So let's start with number 1. A curve is defined parametrically by x of t and y of t. What is the equation of the tangent line to the point defined at t equals 3? So we know that we can find our order pair by plugging 3 in to find x of 3 and y of 3. Those are our order pairs. And then to find our slope, we can just do y prime over x prime. So once we find y prime over x prime, we can create that dy over dx, plug in 3. Okay, so try those steps, see if those make sense. And then you can also use your calculator as well. So I'm just going to kind of help pace us through this review sheet. Give you guys a few minutes to try the first one. Then I'll go show the answer, I'll go over it, and we'll just continue working through. So even though you can use your calculator, I do want to see your calculus steps. So I want to see how you're finding the derivative. I want to see how you're plugging in. But obviously, you can use your calculator to speed up your calculations as well. So dy dt, we can use chain rule. Dx dt, we can use power rule. Put them over each other. Find y prime over x prime of 3. Get the numeric value that's associated with them, and basically are breaking that slope into a horizontal and vertical components. Slope is 1/15, order pair is 4, 5, and then point slope 1. Number 2, object moves in the xy plane so that its position at any time t is given by the parametric equation x of t and y of t. What is the rate of change? So again, right, pretty straightforward there. Find y prime of 1, find x prime of 1, and then just divide them out. Number 3, asking about second derivative in parametric form. Remember, with second derivative, it's a little bit more than what we would expect. Normally, we would just think that, oh, if we just find dy dx and find the derivative of that, then that's basically our second derivative. But if you remember, there's a second component as well. Once you find your derivative of dy dx, you still got to divide by dx dt. So this is the part that that feels not as intuitive here. So we need to include that divided by dx dt even after we take care of the derivative of dy over dx. Number 4, same process, just you're starting with theta instead of t. So for number 4, I'm finding y prime, x prime, and I'm cleaning that up before I go through that process again to find the derivative of my reduced dy dx in terms of theta. And once I find my derivative of my cosine theta, I'm still having to divide by negative cosecant squared theta, because I'm still having to divide by x prime of theta. Number 5, arc length. We can use the parametric rectangular form. Right, if we're good with page 1, go to page 2. And at any point, if you're stuck on anything, just raise your hand. I'll come around and help answer any questions you have. Next one. One. Wait, what's this? That's why I'm not saying you have it. The line punch first. Yeah. Number six, arc length and parametric form, but just in terms of theta. Vector value function should feel easy. You're just doing a lot of derivative and integral process across and just maintaining your horizontal and your vertical components or your yeah, basically in component form. I think it's pretty intuitive, like whatever, yeah, all the knowledge from your previous from previous units kind of just allows you to, doesn't feel like anything new. You're just finding derivative in a different form. Well, this is in terms of data and parametric. So we don't have a custom have time component, so it's going to be this one there. For number 8, you have your x component, you have your y component. Find the derivative of each and just do y prime over x prime. Plug in pi over 6 and get your slope. There is a need for product rule because of each component has two variable expressions built into the function.
So the second one has that will tell us which direction the header and how long it is. So this one. It's really huge. I mean, if I didn't tell you anything about it, just do what you think is going to happen. I think you're right. Small movement with a big one. Um, what would they call this? I think in terms of balance, it's both are emotions going. This is good on this is the horizontal. But that'll be great middle down with the story. It's like imagine this is the X for one. I see you don't feel that's so I think it might be actually I would be the one to go to the internet and thinking about that, but I think by hopefully the news line.
Number 9, you're just taking the antiderivative of each component. And then once you find the antiderivative, you're just going to find the C value for each component and then update the C's from each component to get your F prime up to that. Yeah, but I do want to see all your steps, but once you're here, you can count it. Let's keep going for another 5 minutes.
I'll see you show up. On 0 to 2, -2. 0, y, solve which yeah, I mean, it's absolutely, yeah. And do for this -2. This one. -2 is the x value, so that would be the, yeah. This is this one, how much board on it's not. It's like it's good, but we don't care about the board on it, they're not about it. So we just board docs, we're ready to change the Y. It's good, maybe like. Yeah.
Okay, so tomorrow I'll be checking pages 48 to page 68. I'll send out a remind as well as a link to the key where you can check your answers and make sure you have those for me tomorrow. But tomorrow we'll have another full period just to continue working through your packet. And after tomorrow, we'll need to start 10.1, but we can still use the second half of class to just continue working on our packets in preparation for our Unit 9 test, which will be next Tuesday. Back up in the bus. It's pretty good. Better than my old. Carolina. Would you check for tomorrow? Okay. Then, you know, we need additional time to work on it.
Well, I mean, is it good right now? Yeah, it's gonna be good. It's a month, it's supposed to be. It's consumable, it's gonna wear down.
That's.
I think I'm gonna go